The volume of a spherical bubble increases at a constant rate of 5 centimeters cubed per second. The initial volume of the bubble can be assumed to be 0. Find the rate in centimeters per second at which the radius of the bubble is increasing when the volume of the bubble is 20 centimeters cubed. So it is given that volume increases at a constant rate, so we can say that it's what dV over dt, and it increases, so it's positive, 5 centimeters cubed per second. The next, it's about what a sphere, so we should consider formula for sphere. Volume is what? 4 over 3 pi radius cubed. And then find the rate at which radius of the bubble is increasing. So we need what? dr over dt. And this dr over dt to arise, we should do what? We should just differentiate this equation. And again, it's quite typical situation. There always must be some formula which connects all given parameters, and then you differentiate this, and we'll differentiate with respect to time. We differentiate everything with respect to time. So v with derivative with respect to time, it becomes just dv over dt. Just v, so dv over dt is equal to 4 over 3 pi. It's a constant, so it's 4 over 3 pi. And what is derivative of r cubed? But notice that it's not with respect to r. If you write 3r squared, it's not correct. Why? Because derivative is with respect to time, and r is some function, unknown function of time, and we should apply a chain rule. And chain rule says that if a function is raised to some power, for example sine cubed of x, and derivative, if there is power, we apply the same rule as for x cubed, so it becomes, and keep sine this instead of x, so it becomes what? 3 sine squared of x, and this function derivative, so sine derivative, which is cosine. But if it looks like sine of 3x, when there is no power but more complicated argument, chain rule says that you apply the same rule as for just sine and keep argument, so it becomes what? Cosine of 3x multiplied by argument derivative. And r cubed, it's like this, but r is some unknown function of x, so it becomes not just 3r squared, so we apply the same rule as for x cubed, so derivative is 3x squared, here it's r, so 3r squared, but since derivative with respect to t, not with respect to r, we should multiply by this r derivative, but since r is unknown, we just write dr over dt. The same, actually the same rule here, but v to the power 1 derivative, it's just v to the power of 0, it's 1, and multiplied by dv over dt, and that's why it's just dv over dt. Or you may just remember, if there is like this just v without any power, derivative is just dv over dt. Actually, there may be another way. For example, consider dv over dt, and it is equal to dv over dr and dr over dt. It's like fractions. You can see that dr, it's like it cancels out, and derivative of v with respect to r, so it's like x cubed, and derivative with respect to x, its usual derivative, so it becomes just 3r squared. It's this. But additionally, you should write dr over dt, and you can see that it's absolutely the same. And you can see that dv over dt, it's constant, so it's always 5, so it's always 5. 3 cancel, so it becomes 4 pi r squared and dr over dt. So dr over dt changes with time, and it depends on r, and if we need some moment of time, we should know what the value of r at that moment of time. And what moment of time is required here? When volume is 20. So we should consider just volume, this formula, and volume should be 20, 4 with 3 pi radius cubed, and we need solve for r this and substitute into this, and so then solve for dr over dt. So when v is 20, r is equal to, we can divide by 4, so it's 5, so it's what, 15 over pi and the cubed root o to the power of 1/3, and then dr over dt becomes at the required moment of time. You can, it's not necessary, but you can do like this, or you may write just when v is 20 dr over dt, or you will do like this, v is 20 or something like that. Dr over dt becomes what, 5 over 4 pi r squared. Or we can rewrite that dr over dt in general, it's 5 over 4 pi r squared, and here we just substitute the required value of r, which is 15 over pi to the power 1/3, but it is squared, so 2/3. And you need just what, calculate this, and it's the required rate of change. And using a calculator, I calculate 15 over pi firstly, over pi to 2/3, and then 5 divided by 4 divided by pi, and divided by the answer, and it becomes, yes, it's correct, 0.140, and unit is centimeters, because radius measured in general meters. Here it's centimeters, dt it's time, so per second, centimeters per second as required. And that's all for this question.